Welcome to DesignSafe. We'd like to give you a brief overview of the tool and as it guides you through the risk assessment process. When you start a new assessment, you come to the info wizard and you enter in the machine that you are evaluating. In this case, we're going to do a yogurt dispenser. You can do a process or a product assessment. A product is a standalone or single machine, for example. A process might have multiple machines in a line. In version 9, we've added this new feature called the Guide Me, and this helps people to better understand how they can structure an assessment. We've found that people sometimes struggle with this, so we've developed this feature, and you can see we've got different templates that you can use to help structure the assessment. In this case, we're going to use an individual machine or product. We can enter in the company name. There's places for your name that's conducting the assessment, the limits of the assessment, and the type. All this information prints out on the report, and you can edit it at any time. The information sources that we're using, and the dynamic checklist. Now, we have a variety of different checklists built into the software, which are customized to different industries, with the point being making this faster and easier for you to do. You can also create your own checklist if you prefer to do that. Similarly, we have a variety of different risk scoring systems. You need to find the one that works in your organization, so you can use one of these in your assessments. We break the assessment into 4 different tabs: identifying hazards, assessing and reducing risk, the control system assessment, which is a new addition as a tab in version 9, and then alternative methods, which is also a new tab. The process we follow comes out of the industry standards, ANSI Z244.1 and B155.1, for example. We set the limits of the assessment, we identify tasks and hazards, we assess the initial risk using the risk scoring system, we do risk reduction using the hazard control hierarchy, we assess the residual risk, document whether it's acceptable, validate the solutions and the results and documentation. That's the process we follow. Here we have our yogurt dispenser with our list of users: operator, maintenance technician, passerby. You can add, edit, delete any of the lists throughout the program. The operator is going to be performing these kinds of tasks: normal operation, cleanup, loading and unloading materials. You can even include misuse, loading the wrong material. Maintenance technician is going to be doing other kinds of tasks. At the next level, we look at hazards. And in the middle are hazard categories. On the right side are specific hazards. So everything on the right here are all mechanical hazards. We also have electrical, like energized equipment and live parts, slip, trip, and fall, ergonomics, and so forth. This is the brainstorming function of the tool. It doesn't tell you what to think, but it does tell you what to think about. You work through this to identify hazards, and I'm going to switch now to a different file that's been more complete. And here you can see we've got hazards that have been selected, impact hazards, and so forth. That's how we identify hazards. The next tab is assessing and reducing risk. So we have our user, our task, our hazard, and this grid goes off to the right. I can enlarge it. So we have our hazards. We look at the next piece of this is to rate severity and probability, and we use that using the risk scoring system. Here we have severity of harm. So we have an impact hazard. It might be serious. It's likely to occur if we don't do any risk reduction. As we scroll to the right, then we see it's a high risk level, and we might need to reduce the risk. Here's the hazard control hierarchy I mentioned. Can we eliminate this by design? Different ways to do that. Or substitution. Guarding against a hazard, fixed enclosures, interlock barriers, delayed start, trapped key, light curtains, and so forth. Warnings, training, standard procedures, lockout, tagout, personal protective equipment. This is the hazard control hierarchy as it appears in a variety of different standards. You can also just type in a solution. In this case, we don't have a control system that's involved, so it's not applicable. But in another one, it might be applicable. So when we work with control systems, what we've done now is we've moved the control system to a separate tab. And in evaluating a control system, you can add a control circuit, which might be, for instance, an emergency stop. You can identify the safety function. What do we want it to do? Initiating an emergency stop is one. There's a variety of other different safety functions that can be selected. You can also edit those. We then now need to evaluate the reliability. So we know what the circuit is, we know what we want it to do, how reliable does it need to be. And you rate the severity. It's either S1 or S2, the exposure, and the avoidance to get a design specification. This comes from the performance level specification of this particular system out of ISO 13849-1. We also have other systems you can work with, categories. The control reliability is an older methodology used in the US. There's another method that comes out of the robotic application. It's in a technical report using 3 factors and 3 levels of each, and they specify the performance level and the structure. And then finally, you can look at using a safety integrity level. This is a new add for version 9. So you evaluate your control system, but that's not the end. That just gives you a design specification for how good does the circuit need to be. We need to go back then to the risk reduction section and the evaluation here, and again look at the severity of harm after we have the control systems in place and the risk reduction measures in place. Look at the probability of the occurrence of harm. It's now been reduced unlikely, and that gets us a risk level. The software doesn't tell you whether that risk level is acceptable. That's something you have to do, and that decision you make. The rest of this looks at the status. You can assign a status as either complete, an action item, it's ongoing or whatnot. You can assign a person to it. There's also space for additional information if you wish to put it in, comments or references and such. So that's the risk assessment. You can see that process. We talk now about an alternative method, and we're going to jump back to identifying hazards. And let's say, for instance, that for an operator, we want them to be able to do a task such as cleaning the system, but we don't want to have to lock out to do that. We want them to be able to clean without locking out, or maybe it's clear a jam. We've identified this as a task we want to use for an alternative method, which is great. How do you do that? Well, this comes up to the flow chart for the alternative methods, which is based on the ANSI standard Z244.1. There's some general information we need to evaluate in terms of the feasibility of lockout, tagout, the justification for using alternative method, and industry best practices. We have to do a risk assessment, which is that's a requirement under the standard, which is great. We've done that. Then there's some technical aspects of evaluating the control system, and the tamper resistance and the fault tolerance. Exclusivity is something that's very important to OSHA and very important to us. And then there's programmatic things like the tasks, the task list and the program and the review by a qualified person, which goes into your technical file. That's the process that we guide you through in this alternative method tab. Talks about, there's an awful lot of guidance information trying to help people understand when you can use an alternative method and why and what's required. So, and you can certainly, as a designer of a machine, you may want to use an alternative method to increase productivity of your machine and make your customer happy. As a user, you have the same interests, but you don't want to get into trouble if OSHA comes knocking on your door and you're not locking out where they say you should be locking out. So this tool guides you through the process. You identify why lockout, the feasibility of lockout. We've got a number of different checklists here that you can work through. the justification, why are you using alternative method. The risk assessment, you can either use the one associated with a designsafe file or an external one if you wish. The technical evaluation of the control system, which of these circuits are part of this, and then looking at the safety principles and well-tried designs, looking at the architecture, is it appropriate for the level of risk, tamper resistance. Locks have great tamper resistance, much better than tags. Interlock switches might also have tamper resistance, depending on whether you can tie them back or not, or it's a purpose-built switch. You evaluate the fault tolerance, the exclusivity. This guides you through the elements required for an alternative method and helps you build the technical file that you put in place when you need it, if OSHA comes knocking on your door or you encounter an internal audit, for instance. All this information with the risk assessment and alternative methods can be viewed in the reports. We have a variety of different reports. Once you have the data in here, you can slice it and dice it in different ways, of course. I'll just pull this up as an example very briefly. So the information you put in at the information wizard appears at the top. You've got your user, your task, your hazard and failure mode, your initial risk level, risk reduction and the control system if it's applicable, your residual risk, and the status and person responsible. Those are the reports, and you can see there's a number of them. Other features in here, we have help in terms of videos as well as written. You can guide you through this, and resources. So there's guidance on shortcuts, how to make this process speed up and work faster, more effectively. There's guidance on what to do. There's some content on standards, some one-page summaries of different standards. This is a tool is intended to help guide you through the risk assessment process and to make your work more effective and efficient and help you build better machines and better systems. We hope you like it.